I am Rian, and today we will be talking about the different conformers of butane. In our stereochemistry class, we learned that, in contrast to double bonds and triple bonds, single bonds are able to move freely and rotate in space. So when we talk about the conformers of a molecule with all single bonds such as butane, we are mostly referring to how the molecule looks like and is arranged as we rotate the molecule at the single bond between the second and the third carbon. Hence, it is worth noting that when a molecule experiences more steric strain, it is less stable because these bulky molecules would want to repel each other. Let us now look at the structure and the conformations of butane. Here we have our butane molecule represented by our ball and stick model. The black balls represent our carbons and the white balls represent our hydrogens. Looking at our molecule, we can freely rotate all three single bonds. However, we will be taking a look at the single bond at C2 and C3 and view our molecule facing that way. Our first conformation is the eclipsed conformation. This occurs when our two methyl groups are directly in front of each other and has a dihedral angle of 0 degrees. We can also observe this with our hydrogen groups. If we rotate C3 60 degrees clockwise, here we have the gauche conformation, which is similar to the staggered conformation. This occurs as the two methyl groups are at a 60-degree angle. If we rotate C3 another 60 degrees, we observe that we have obtained another eclipsed conformation, as the three groups connected to C2 and C3 are facing each other. However, our methyl groups are at a 120-degree dihedral angle. Lastly, another 60-degree rotation gives us a staggered conformation, which we call the anti-conformation. This is the most stable conformation as the molecule experiences the least steric strain. This is because the two bulky methyl groups are at a 180-degree dihedral angle, the largest angle among all conformations. We can take a look at this energy diagram depicting our four butane conformations and relate them to their stabilities. The conformation with the most steric strain is the first eclipse conformation, since the two methyl groups directly in front of each other experience the highest repulsive force, leading to less stability due to higher energy, while the anti-conformation is the most stable, as the methyl groups are at the farthest from each other. Meanwhile, the second eclipsed conformation is more stable than the first, since there is less steric strain from the interaction between methyl and hydrogen, while the gauche conformation is less stable than anti, as the two methyl groups are closer to each other than at the anti conformation.